Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to graph polar equations. And for this purpose, please have your graphing calculators ready. And don't forget to put them in the polar form. And we have three different graphs. And at the end, once we're done with graphing, we will also try to come up with an interval for the parameter theta in each case so that the graph is traced only once. And I'm going to explain what that means for the rest of the video. And I want to give you like short heads up for you just to see like what to expect for the rest of the video. For the first part, you have something called cardioid, so the graph of the cardioid. So this is what we're gonna get in the first part. In the second part, we have an ellipse. So unexpectedly, 1 over 4 minus 3 sine theta defines an ellipse. And finally, we have a very special curve here, r squared equals 1 over theta. That's a spiral, spiral that spirals out, starting from 0. And we have two different versions of that, but I will mention all of those in the video. So, and I think I'm going to split this question into 3 separate videos, and I will handle each case in those videos, separate videos. All right, so have your calculator ready. Let's get started. All right, let's look at part A. We're going to use a graphing utility, so please have your TI-84 ready. And we're going to graph r equals 4 plus 3 cosine theta. You can go ahead and put like minimum value for theta and maximum value for theta. One thing that we know from trig is that cosine is a 2 pi periodic function. And it's natural to start with theta equals 0 for theta min, and obviously theta equals 2 pi for the terminal degree. Okay, so because that's one full period. So go ahead and graph it, and you can pause the video anytime. Let me show you what I got here. So essentially, when you try to graph it like the way I did here, remember that these are the rays, so this is theta equals 0. I use the degrees, by the way, but you can use the radians. I just wanted to sort of like emphasize those degrees to you, but in your TI-84, you won't be able to see those units all the way. But what you can do is that to be able to like sweep one full circle here, so you go with all the rays here, okay? And make sure that to be able to get like one full loop starting from here, because this is what theta equals 0 spits out. Okay, so if this is theta equals 0, and then the corresponding r would be like 4 plus 3 cosine 0, and if you just evaluate that in your calculator, that's 7. That's exactly where we end up here. Okay, so essentially on the right, theta equals 0, we're going to walk like 7 units, okay? 7 units, and then you end up being here, okay? And then go ahead and look at theta equals 15, even though you have a full picture, so sort of like convince yourself along the way that you get something like this, you get something like this, something like that. For theta equals pi over 2, you get the 4, because at pi over 2, cosine pi over 2 is 0, so your r is 4. That means you're walking only 4 units all the way to that point, okay? And then keep going, and you will see that once you hit all the way to, like you just go all the way to 2 pi, that means that's one full loop, and you should go back to where you start here, okay? And then the direction that you go, if you choose theta min to be 0 and theta max to be 2 pi, you're going on going with this kind of like orientation on this curve, okay? I think that's what the question is originally asking for. Find an interval for theta over which the graph is traced only once. So you're using some information from some knowledge from trig that cosine function is a 2 pi periodic function, and for that reason, choosing the theta min to be 0 and theta max to be 2 pi is very wise. So I'm going to go with answering this question completely, saying that, you know, so theta should be in between 0 and 2 pi to get the one full period, and you don't need to put equality sign here for 2 pi because that means that you're repeating yourself, right? Because theta equals 0 is the same as theta equals 2 pi for cosine, right? Because it's a 2 pi periodic function. So it's better to just keep 0 over there and then going all the way to 2 pi. All right. Let me take care of also part B in this video because it's similar. It's a similar analysis. We have sine theta here, and we know that sine theta is as well 2 pi periodic. And please go ahead and use your TI-84 to graph 1 over 4 minus 3 sine theta. And choose your interval the same as what we had earlier. Put the equality sign to 0. Okay, so we have theta is ranging in between 0 and 2 pi, and go ahead and graph this function, and you will see that this is going to be an ellipse starting from 0. So like this is your first ray, another ray, another ray. This direction, obviously, counterclockwise is always positive for thetas. Thetas are increasing in that direction, right? So theta equals 90 degrees, in other words, pi over 2, 180 degrees. And 270, and on and on and on. Okay, so make sure that every time you calculate R on these rays, you have those points marked, and you can actually see full loop over there happening with this direction here, right? We're going in this direction. And starting from 2 pi going forward, you'll have the repetition of the graph over there. Okay. Because this time, let's say like 15 degrees is going to be like 2 pi plus 15 degrees, or in other words, 360 degrees plus that, right? So, and sine is going to take the same value as like sine 15 degrees, because sine is a 2 pi periodic function, okay? So please make sure you sort of like use this piece of information from trig that sine and cosine are both 2 pi periodic functions, and we're using the power of that knowledge to understand or to answer the question being asked in this question. So I think that takes care of part A and part B. I'm going to continue part B in the next video. Please continue that, and I'll see you over there. Bye.